back again. I only got a very short break from my last presentation, but what we have now is a panel session. The panel session is to look at the evaluation of retrofit. So we talked, and I think lots of people today have talked about how we undertake retrofit, what it looks like. Yeah, it's nice to see familiar faces as well in the audience listening. And this really now is to start to think about, once we've undertaken this deep retrofit to a property, how do we evaluate that my investment, my hard-earned cash has been spent on the right proposition, the right input, and how that really then starts to ramp up in how we think about this in different ways. So we think about deep retrofit, we think about in terms of the scale of retrofit. So if we have to do 24 million homes, then how do we evaluate 24 million homes? But also sort of look at the broader challenges that come with that, and whether actually a consumer needs to know. So it may be that this is partially invisible to a consumer, but it's in the background running, and it's how those apps come. And we have three very distinguished people with us today. So we have David, Richard, and Tom. We've got roughly a 10-minute presentation from each of them on their views around retrofit, and then we will open to a panel session for questions. So can I ask David, you were on first, if you would, please.
Thanks very much. Can you hear me okay? Good. Right. Thank you very much for the opportunity to come and do this talk. I'm going to give the academic approach to evaluating building performance and retrofit specifically. So there may be some things that will be completely irrelevant to you, you'll never see, but I think it's useful to understand the building physics, the science behind evaluation, and where the tools that you might actually come across originate from. So what I'm going to do is talk about a specific research project that we are just about to launch, which we're very excited about, and we'll be talking on Thursday in the Department for Energy Security and Net Zero innovation stage, so you can hear more about it. And I've just been told that the video that I put in the slide that you'll see in a minute doesn't work, so I'll be a bit quicker, or it means I can just spend longer talking about the rest of the slides. So it's probably a good thing. So my name's David Glew. I'm a professor at Leeds Beckett University. I'm the director of the Leeds Sustainability Institute. We have a heritage of around 30 years plus of building performance evaluation. We are developers of the co-heating test, which is something I'll talk a little bit more about, and that's we're very happy that that's been accepted as a way of undertaking building performance across the world, and there's lots of international standards being produced about that, and we'll talk some more about that. The project itself I'm going to talk about was funded by the Department for Energy Security and Net Zero, and they've been very concerned, I should say, around domestic retrofit for quite a long time, and it's really nice that they're investing money to work out how to do these things safely, and also how much they're going to save. So there's two different approaches, or a couple of different approaches to doing monitoring and evaluation. You can do something in a really, really detailed way on a small sample of homes, or you can do something on a large sample of homes, but obviously in a more cost-effective way. So that's going to be, I think, the theme across the talks today. Hopefully we'll be in a synergist, a kind of nice, sympathetic way. You can see where they complement each other, and they're not in conflict at all, we hope. Okay, and that's just a lovely picture of a home with external wall insulation on it. Right, so my research group has undertaken a couple of different research projects that you can have a look at here. One's on thin internal wall insulation, so do they work, how thin is too thin, and how thick does it need to be before it starts causing you moisture problems. It's a very specific issue. If anybody's interested, you can find that on the BEIS website, or Department for Energy Security website. We did a Core Cities, which is a whole house retrofit research project, and lots of the similar things I'm going to talk about today are involved in that Core Cities project too. So I'm only really going to talk about fabric retrofit evaluation. There's lots of social science that you can do, and one of the three themes of our research group is to investigate the impact that retrofits have, or buildings have, on people, which arguably is the most important thing. That's why we do it. But I'm not going to talk about those types of retrofit evaluations today. I'm going to focus on the actual techie fabric stuff. The second theme in the research group is sustainable buildings. So the people sit inside the buildings and we look at designing, building, measuring those in a sustainable way. And then the third theme is kind of the buildings, they sit inside the context of an urban landscape or environment, and that's our third area. Air quality and that sort of stuff. Okay, so video there, which is not going to play, so we can just jump straight to, it was going to describe in a really lovely, snappy way that I can't reproduce now, just why we did the research project. But we can look at the detail now. 14 homes, we undertook step-by-step retrofits. Lots of different retrofits going on in these homes. Not every home had the same retrofit, but they were all solid-walled homes. We wanted to identify the disaggregated impact that each of the individual measures had in terms of energy performance and thermal heat loss reductions, as well as moisture risks. So when you do change the building fabric, you change the building physics, you change the way heat moves, and that heat influences moisture. So that's important too. So I'm going to talk about the types of tests that we did. So this is the co-heating test. So it looks a little bit alien, a bit bizarre. There's kind of some heaters, some fans, some little red dot things on the walls. These are really intensive, intrusive tests that we do. We can't have anybody living in them. We need to have the house for minimum 2 weeks, ideally 4 to 5 weeks. We heat up the home, we hold it at a steady temperature, we measure exactly how much energy we're using. We know what all the temperatures are inside and outside the home. We try to create what's called a quasi-steady state environment. We're basically trying to recreate something like a laboratory out in the field. You can't, it's impossible. The wind, the rain, the sun all gets in the way, and that's just life. And that we've been experts now for the last decade or so of trying to rationalize those impacts on our measurements to work out how to kind of get rid of them from our analysis, if that makes sense, so that we can pinpoint the measurement of the building and the benefit of the retrofit. I won't say much more about that, except those little red dots stuck to the wall. They're part of the co-heating test because we also measure U values at the same time. So this is called, they're called heat flux plates, they're heat flux density measurements, and from that you can convert the output from the heat flux plate into a U value for a fabric element. So we went through and we did over, I did have the number. So 43 retrofit. It's probably the largest retrofit evaluation project ever undertaken. 43 co-heating tests. If you think each co-heating test has to take over at least 4 weeks, it's a huge undertaking. This is not a small project that we did. It took us 3 years to do as well. So 410 individual heat flux plates across those 14 homes on lots of different elements to try and measure the before and after thermal performance of individual elements. I won't talk about the importance of actually trying to measure the heat loss going into the neighbour, other than to say that it's an absolute nightmare and completely messes up your tests. Okay, so that's really good for us to do both of these things. So the whole house heat loss coefficient, heat transfer coefficient, is the overall energy efficiency of the home, so one value for the entire home, which we can then compare against the modelled value, so what the models say it should have, so we've got something in terms of that. And then the individual elements as well. Can we compare what we've measured to what the model's predicting it should be? So there's 3 types of heat loss. That's the fabric plane element heat loss. The second one is the one you might be aware of, and that's the drafts, the leakage in the house. So we're able to undertake some tests with blower doors, as well as some of the new test methods that are being developed to work out how much ventilation heat losses we have. And this is where we lose air through cracks and gaps in the building. Okay, so we can do that. So we did over 118 at every single stage of all the different retrofits to see if installing loft insulation, for instance, actually affects the air tightness of the house, or wall insulation changes the air tightness value of the house. Okay, I've got something down there called co-pressurization because we've identified a phenomena which hasn't yet been identified, so we're quite excited, although it does have rather large implications for the blower door industry, that we are observing around 10% interdwelling air exchange when we are doing a blower door. So unless you're pressurizing the neighboring property to exactly the same pressure as the test building, you may be over-reporting your indoor to air door, internal to external heat losses. People who understand that sentence know how important that is, but most people won't really care. Okay, and then the third type of heat loss in the building is thermal bridging heat loss. So this is the heat loss that isn't attributed to the plane element, but it is still a fabric heat loss, but it's just where you get the joints and the corners of different elements interacting. It's just the way that heat moves through fabric. You can't measure those, you have to model those. So we were able to model every single junction in a building, which could be tens of different junctions in buildings. So that's how many we did. And again, we can compare the value that we're modeling against the value that is assumed to be lost. Okay, so we did all of that effort. How long have I got, Simon? Am I over already? I'm over already. Okay, so the problem we've got is even with all of that excessive amount of effort, we can still only measure it within about 5 to 10% accuracy. So if you're going to install a retrofit that's only going to save you 4%, how are you going to measure that? That's the big thing. Doesn't mean you can't measure it. This is a graphic to just show where they all fit neatly. We're over there, really expensive, really sort of accurate, but actually we're totally cost prohibitive. So what you need to do is find out what you can do that you can actually afford to do, which is what next speakers are going to talk about, and those sorts of things are still incredibly useful, and you know, I'm very happy that we're going to hear more about those tools. Right, thank you very much.
Thanks, David. If I could ask you all just to keep a note of your questions, and we'll do them at the very end. We'll just go through the speakers first. Richard, would you like to take us?
Hi everyone, I'm Richard. I'm the Technical Director of Build Test Solutions. We're just next door. If you want to come and see us afterwards, I encourage you all to come and say hello and see some of the kit that I'm going to talk about. So our mission is to make measurement mainstream. So we've just heard that some measurement methods are super difficult, super expensive, but can have really exciting results. So what we're trying to do is make measurements that are a little bit easier to apply, so we can apply them to more buildings. It's probably going to have an impact on the precision of the measurement, so we might have slightly less precision than what we've just talked about, but the same accuracy. So we're going to have a result with a larger confidence interval. So less precise, just as accurate. It's like getting your darts all in the same place or getting them all on the boards. That's the old analogy. So what we're trying to do is make measurements that are sort of cost comparable with the business as usual, by which I mean surveying tools. So we're not looking to cost the earth, so that you can do this on every single building. That's our vision. We want them to be not super complicated, so they can be carried out by the existing surveyor network. So some of our measurement methods, depends which one you go for, but they could be an hour's training course, they could be half a day's training course, or they could be a day's training course, but it means that you can get up and using the kit quickly. And they've got to be non-disruptive to residents. So for this to be practical at scale, we've got to be able to do them while people are in the house without disturbing them too much. So I just wanted to take a little second to stop and say, why are we going to bother measuring the performance of houses? Here's a housing estate in Croydon in South London. 10 different houses, each bar on this chart is a house, and we measured the overall heat loss from every house. All the houses were built to the same design, on the same site, at the same time, by the same builder. They are the same house until you go and measure them and see they're all different. So what would be the right thing to do with each of those houses? On average, our survey was actually really good. We were only 1% off on average, but specifically each house varied. So the house on the left probably needs something different done to it to the house on the right. So the measurements allow you to think a bit more detailed about what I'm going to do with this particular building. What's the right heating system? Should I be looking at fabric first? That's why we're doing it. Now I'm going to try and give you some examples of things that we're doing, and hopefully you'll all go, God, I want to do those too, and come and see us next door, see the value in what we're doing. So here's now a low-rise tower block with around 30 flats, and we measured, first of all, the overall thermal performance of every flat. And then that chart showing the average difference for ground floor flats, mid-floor flats, and top floor flats between the predicted and measured heat loss. So are these flats what I think they are? So the ground floor flats and the top floor flats pretty much what we thought they were. Not a big performance gap, a little bit of a performance gap, but not massive. The mid-floor flats were way worse than we thought. So we thought, it was probably something about the design of those mid-floor flats. They were all worse than we thought. And what we highlighted was a particular defect where you can see this big exposed area of floor and ceiling. They're maisonette, so you get two of them on each side, and it creates a load of extra heat loss. We followed up by doing an infrared survey, and they glowed in the dark when I was out there in the morning at -3. And we measured the U values and saw, this is a real big source of heat loss. So then we could see, this is a good block to target for a retrofit, and when we do it, this is a detail we must address. So it ended up being, they were enclosed within a warm space to deal with that source of heat loss. So now, this is a friend of mine, Zach, who runs a company called Soap Retrofit, and he measured the overall heat loss from his house in Bristol, and he found that the measured heat loss was 80% less than the predicted heat loss for his flat. He's thinking about putting a ground source heat pump into his flat, and suddenly he needs to supply 80% less heat. Massive difference. That means he can have one less borehole. It was a ground source heat pump with 4 boreholes planned, only needed 3. He had a 15% saving in his capital cost, and the heat pump should run more efficiently because it's better sized for the house. So that's a slightly extreme example. Not all houses are that different, but it's not that extreme. We observe it fairly regularly, so he's been able to say, this is the right thing to do for this particular building. Last example. So we're retrofitting buildings, and we're thinking about what's this going to do to the air tightness, what's this going to do for my infiltration, what therefore should I think about my ventilation provision. So by measuring the air tightness before and afterwards, we can see what effect it's had on the infiltration to the building, which in this case we're relying on to give us enough fresh air. So in this case, we did cavity wall insulation and some draft stripping, and the building did get more airtight, 32% more airtight, but actually it was still reasonably leaky. So we could think, actually, I've got enough fresh air in here, I don't need to put more holes in there. But we also measured the airtightness of every room and found that one of them was still quite airtight, so we wanted to have a door undercut into there to make sure we could get fresh air into that room in particular. And this is a standard, a method to work by that's run by the Insulation Assurance Authority, using airtightness measurements as a tool to be informed about whether we need to put more holes in or not. That's a really interesting debate, which I'll be happy to have. And that's me. Thanks very much. Look forward to some questions.
Okay, thank you. Thanks, Richard. We've got 2 views, a third view to come, and no presentation on this one, but Tom is going to talk to you. Tom, over to you.
Hello. Thank you very much for having me. Thank you for the 2 very good presentations before. Yes, I've been doing retrofitting for about 30 years now, and I look way younger than that. Retrofitting and evaluation is like a very peculiar case of Schrodinger's cat. It's only ever alive if you don't open the box. But when you do look in the box, it's almost always dead, and half the time it's already rotting, right? So that is a problem, right? We really don't check, we don't measure, we assume, and we just get on with it, right? The problem I've got is that I almost always look into the box because I'm too curious. Now, before you start imagining me surrounded by dead cats, I'll give you an example from real life. At Qbot, where we insulate floors with robots, stand 830, you can go and play with the robot if you want. We do check every single property before we go in. It's very critical, for example, that we understand the moisture content of the timber before we encase it in insulation. And it seems obvious, but how do you check that? When do you check that? Where do you check that? So, an example, a surveyor visits a property in winter, opens up the floor, takes the moisture reading of the floor joists, and it's 18%. Brilliant. we can go ahead. We schedule the installation. Few months go by. A team arrives in July. They check the moisture content again, and it's 23. And the installation is aborted. Why is there such a huge difference, right? Well, the moment you start measuring and looking at buildings long term, you'll see that there is a natural oscillation in humidity and moisture content of timber between winter and summer. And in the summer, as cooler air comes into the floor void, you've got higher humidity. In winter, the air coming into the void warms up, humidity is lower. So there is a question of when, right? The result you will get will depend on when you measure. Okay, fair enough. Where you measure. Yeah? Again, another job, surveyor comes in, opens up the floorboards in the living room, 16% humidity, brilliant, we can schedule the installation. Installers turn up, open up a hallway, and it's 32, right? So suddenly, in between different locations in the house, you could have completely different moisture content within the timber. Yeah? On one side, totally safe. On the other one, yeah, in high danger of rot. Right? And you've got local factors that can influence that. In this particular case, there was a patio sloping the wrong way, and the brick vents in front of the hallway were covered. But again, you can't just measure in one place, right? And then, at what stages of the installation you measure? Do you just measure after you've done the job? Or do you just measure before you do it? Right? Or do you measure during? Another case, we surveyed the property in the summer. The floor was declared safe to insulate. And then it was done as part of the retrofit. External wall insulation went in first. It was first week of December last year. Somebody decided that it will be a good idea to insulate below DPC, which is fair enough, okay. Jury's out on that, but fine. But as they were doing that, they decided to cover the brick vents. Right? So our installer turns up first week of Feb, and the moisture content is 38%. There's actually droplets forming underneath the floor timber. Yeah, so within 2 months, in winter when it's supposed to be the driest, we had moisture content and void humidity go up from 16, or moisture content in this case, to 38. Incredibly unsafe. We're looking at months before the rot sets in for good. Right? Again, the installation is aborted. We don't proceed with the job, and we identify the site as risk. Now, if you take all of that into account, right, it sounds like you need to measure everything, everywhere, all the time, right? So we can look at it in two different ways. We can look at it and say, oh, that's not possible. I mean, there's no way anybody can measure all of the different variables, right, in the building before the commencement of retrofit, during the retrofit, just to make sure that we pick up whatever issues might have been created, and after the retrofit. I mean, it's just too much. It's too expensive. It's impossible. How can we possibly do this? Or you could look at it the other way and think about the fact that, you know, an average new car measures 6,000 different variables every minute. And I can't see anybody complaining. They actually, you know, the industry sees it as a very beneficial thing because they can optimize, you know, the engine control units. They can optimize all sorts of other things, right? If you look at how cheap things have become, and I mean, who's got Blink camera? You know, you've got those camera connection units that plug into your home Wi-Fi. They cost like £30 to buy, right? If you start looking at how much sensors actually cost, a PT1000 temperature sensor, which is relatively accurate, right? Costs £2 on Ayers components. It would cost you 40 pence if you were to buy a volume. Right? Humidity sensors, you can obtain them for £4 or less, right? If you buy them at volume. CO2 sensors have gone down to something like £30, right? A GSM modem you can embed into your PCB for 20 quid extra, right? You can have a SIM card, a data SIM card, for less than £1 a month. Yeah? So when it comes to data collection, data handling, and data processing, we've never had it so cheap. Right? But at the moment, we're still focusing on, the industry is focusing on resisting, rather than accepting that, well, we might as well measure everything all the time and everywhere, and then look at the volume opportunities that this creates. Look at the markets that it can create. Right? What if we have an open source format? There's something like government tried to do for Code for Sustainable Homes, right? That there was a website, people were supposed to upload the data. Industry hated it. Yeah? But what if we have an open source, single standard, where every property that's being done uploads the data continuously, right? And then we can have a complete new ecosystem, or developed around analyzing that data, maybe coming up with different ideas of optimization and so on, right? But we need the acceptance that, well, actually, if we don't measure everything, everywhere, all the time, we're never really gonna know. Right? So that's my point. Thank you.
Thank you, Tom. Right. We would like now to open for questions to our panel. So, anybody like to open the questioning? Gentleman here. Want a good microphone?
It's interesting. Hello? Yeah. You're mentioning Schrödinger, which I know a little bit about, quantum mechanics, very interesting. I think we know a bit more about buildings than what electrons do. Yeah, what he's saying, we could measure it, and I think you were saying that, and we have technology. My question's a matter of logic, I think. If, as a surveyor, yes, I can measure something. I very rarely lift up floorboards, but maybe I'm doing a different job from the surveyor you've got in mind. But this humidity level, one thing. Moisture content, yes, I agree. Anything over 18%, certainly in softwood, is not necessary, but it's certainly a condition that is it's not sufficient. It's a necessary condition. But knowing everything, everywhere, all the time, you only need to know it's a certain moisture content at any time. How does it help knowing all this information? If you've got it at 38%, you're going to say, oh, we really shouldn't be installing it, or whatever your criteria. So I don't know how more information is going to help the situation, how you overcome the problem of moisture content. Could you explain that? And are there ways of getting the moisture content down so you can fit?
Yes, of course.
Yeah.
The reason why the cat is always dead when we evaluate retrofits, because they never perform as expected. When I look at the building, I see a whole number of risks, weak points, intersections where you can have either interstitial condensation, or you've got some thermal bridging, or you've got some thermal bypass going on. There is quite a lot when it comes to a building. And whenever we look deeper, we learned that actually our assumptions were wrong. Whether you look at the paper that came from Cambridge in Jan this year, which said that, loft insulation only really benefited, reduced the heat loss by 4% rather than what we estimated. The cavity wall, 7.5. After 2 or 3 years, there was no measurable impact from loft insulation, for example. So you've got papers coming out. You've got David's research that I'm looking forward to reading as well, where the answer generally is, well, we don't really know. Again, there are different levels of accuracy of measurement, but moisture content is not just a matter for floors, right? We know from, for example, the loft insulation issue, right? That moisture content in timber is important when it comes to roofs. Moisture content in walls is important because you've got spalling, you've got reduced performance of insulation, wet walls lose a lot more heat. When it comes to risks in retrofitting, there are so many areas where you can fail that visibility is something that can actually save us, because you can pick up issues that develop over time. Even you can possibly have an idea of an airtightness of the building by just monitoring pressures of supply and extract in the MVHR, for example. So if you measure everything all the time, and these guys, building services, can see quite a lot. I mean, you've got a temperature sensor and a flow sensor. You know exactly how much heat is going into the building, how much cold. You don't need a complex heating monitor. You can just monitor simple things, and from that you can get quite a lot of information, and then that can lead you to understanding that, okay, things are not performing as well as before. Maybe we should evaluate that again and see if we can fix it.
Thanks, Tom. Can we hear from Richard and from David as well, please?
Oh, well, specifically on that one, I guess the example was something else happened to the building and the moisture value changed. So I really like maybe it's just because it's catchy. People measure everything everywhere all the time. It's really nice. I imagine there's probably ethical problems with that. You know, people knowing that your data is going elsewhere. We've had a huge problem in terms of trying to sign people up to give their data away for very good reasons, data protection, and people don't like people to know what's going on in their homes, etc., etc. And I'm not an expert on it, but I appreciate it's a complex issue.
Richard, anything to add?
Not loads. I think I'd say that really there probably is a lot of data being collected in your house. There'll definitely be things already that are measuring the temperature. There should be something that's measuring the energy consumption so someone can bill you on it. They're really some of the most important things, so it's probably about how you use the data that's being collected, and that's a bit about how it's being shared, but also about what you decide you want to do. If you've got a real valuable insight that you want to get, then people will probably give permission. If it just says, share my data and something might happen, then it's probably less likely.
Lovely, thank you. I think it's worth adding as well, one of the projects we worked on in the devolved nations, where we were looking at working with organisations installing data collection devices, a high number of the consumers refused to have the work completed because there is a real challenge around data, and we have to overcome that. And I think there's an element of overcoming those challenges so we know or have better information so we can use science to drive what we need to go forward. So thank you for that. Questions?
That was quite a good lead on, actually. As much as kind of me personally, I probably would like to have instrumented everything and all the data to find out where air is going and etc. Monitoring comes with its own carbon footprint as well, and so we can embed stuff that's just there, pre and post evaluation, which would be great. But if the monitoring equipment is buried in somewhere doing nothing, not providing any meaningful insight, that's kind of wasteful when we should be aiming at zero waste overall, including in our electronics.
Who would like to say that one?
Yeah, I think I'd say exactly the same thing again, but you've got to decide what you're measuring and for what reason, decide that it's got value, show what you're going to do with it, and then I think that risk should be abated.
Gentlemen, anything to add? No. Nigel.
Firstly, I think there's a very real danger of comparing a property suitability assessment with monitoring and real-time data on evaluation. My question is with all of this testing we're now doing, and I'm a big fan of testing, is it telling us anything that says we are to one extreme or the other? Because at the moment we have standards based on calculated performance. Testing gives us the real-time data. At what point does that data help us shift that risk matrix back towards common sense? Because 19 million properties to retrofit, monitoring everything all of the time is simply not feasible.
I'd take the last statement as a challenge. Yeah, I think it is feasible and we ought to do it, but that isn't what you asked. I think the more we measure, the more we find out for sure. So we're at the moment doing an interesting project with the Energy Savings Trust, where we're comparing the predicted and measured heat loss of around 600 buildings. Pretty random sample of buildings, so few new builds, lots of old builds, and I went into it probably thinking we're going to find a big performance gap, but the really interesting thing is that on average our performance gap is tiny. The prediction was accurate on average, but only 40% of the buildings had the right prediction, so the other 60% had the wrong prediction. Some of them were better, some of them were worse. So actually, you know, maybe it's turkeys voting for the opposite of Christmas. But what I'm finding is that buildings are generally not what we expect, and therefore it is sensible to think of them on an individual basis. And if you thought of any design process, then putting your cost into any building process, putting your cost into the design is generally thought to be a good idea, so that if you don't know what's going to happen later, you're going to get unexpected consequences and problems, so the earlier you can find them, better you can deal with them.
I think I think it's like any good science. It's your method is determined by your research question. So it depends what you want to find out. So for us, in an academic setting, we very much are really keen to look at things in detail to identify specific issues that have generic consequences that we can then kind of give guidance on. So we will do that around the particular way that you would insulate under the damp-proof course, for instance, and then we can provide information to industry based on a very small sample of some intensive tests to say, do you know what, it's probably fine. I think, you know, more commercial tests which you apply on a larger scale, you know, their research question might be slightly different. It might be not trying to give guidance on specific details, but saying, well, generally, did it go all right? You know, or did it go completely wrong? And that's a really good question. They're really useful for that. That keep people keen. You know, all the builders and the installers putting the retrofits in. You know, we do see some pretty shocking examples of lackadaisical approaches to work, and these sorts of measurements, they would pick that up. They would, like, genuinely no cavity wall insulation in this brand new house. Well, that you know, VTS test would pick that up, and it's a different research question, and perhaps that's the most sensible approach, is to determine what your methodology and your methods are based on what you want to find out, I guess.
Thanks, David.
I just wanted to go back to what data can do. And yes, talking about cars again, I'm sorry. If you look at efficiency improvements in cars that were made over the last 10 years, that's all down to measurement and data collection. That's about every manufacturer collecting data from every vehicle that was out there running and using that to optimize the performance of cars going forward. I think maybe we just stuck in a different way of thinking when it comes to our buildings, but I'm not sure there are cars that are as expensive as our buildings, or where we spend as much time, or that have as much impact on our life. Our buildings are a lot more valuable. They're used a lot more of the time. They cost a hell of a lot more. For most people, the only asset they ever have, and yet we're treating them as some sort of medieval caves that, you know, don't deserve what most technologies around us already have.
Thanks, Tom. Another question.
Hi, I'm Alice Monty from Equans. I've spoken to Tom before. We have a nice shiny pulse kit that we use for pre and post airtightness testing as well. I would love to do more monitoring and evaluation on projects that we're working on, retrofit coordinator and everything like that. Contractor side, it's a hard sell sometimes to do more monitoring and evaluation. Clients usually look at, you know, why would we be doing extra than what's required? My question, we've spoken a lot about PAS today and PAS 2035. Monitoring and evaluation I thought this was going to be about kind of monitoring and evaluation under PAS. I'm quite glad it isn't, because there's been a lot more information. Do you think PAS does much to encourage the kind of techniques that we're talking about here? Or would you consider it a little bit underwhelming in terms of that kind of approach at the moment?
Who would like to go first?
So let's start with that. PAS has done amazing things when it comes to focusing people's minds around what actually should be part of a retrofit. Before PAS came, it was anybody's game, right? So PAS has been great at developing understanding, of, for example, things like ventilation. Nobody knew it was needed before. So it's great. At the same time, things move forward, industry adapts, and we need to keep setting new challenges. When it comes to measurement and evaluation, if you, at your scale, say, well, actually, this is how we're going to do it on every project we do, and it's going to be 10,000 projects next year, right? Suddenly, there is a business opportunity that could go to the market, saying, okay, this is what we want to see. That's how we want to evaluate. We want 10,000 of these. What can you do it for? You are creating the market by committing to the demand. And until something like that happens at the scale that you can influence, we're going to be talking the same thing for the next 5 years at the same show, and it's always going to be interesting, but it's never going to lead to anything.
I'd just say very quickly, we as a university even get asked to come and evaluate commercial schemes under SHDF or EDRF. And we also have things like PhDs where we look at how other people are evaluating retrofits. And that's quite revealing. We've got a project with the UK Green Building Council and Leeds City Council. We're investigating whether or not you can standardise a retrofit evaluation programme. And as part of that, the PhD student is observing how commercial providers are providing retrofit evaluation on schemes. Every scheme's got its own funding requirements. Every scheme's got its own monitoring verification requirements. And pretty much every scheme that we've observed so far has got pretty awful data. Not enough pre-data, not enough post-data, not enough time in the programme to do it. So when PAS monitoring verification requirements become part of formal contractual procurement, I can see it being incredibly useful, but currently we've got a situation of a little bit of the Wild West. Anyone can do anything, and you just hold your hands up and go, oh, it went a bit wrong, sorry. Whereas really we can do better with a bit more thought and a bit more planning, and that's not the people doing the retrofit evaluation, it's the people paying for the whole thing in the first place, working out how to include that cost and time within their programme, which currently under very, very fast, rapid turnaround projects and funding opportunities that local authorities are trying to spend the cash as quickly as possible, it just gets dropped. And we're seeing a lot of projects, it's just a complete waste of time, sadly.
Thanks, David.
But yeah.
Richard, anything to add?
Yeah, I'd say prior to PAS, there'd probably been barely any air tightness measurement in existing buildings, and now there's quite a lot, and we're learning stuff from that, so it's encouraged that. But I think when we wrote it, that was really the only measurement show in town. So it does describe in PAS that you might monitor internal temperature and relative humidity and energy consumption, but it doesn't really say why you do it. So I think the next thing, the next innovation on it would be, if it were me writing it, well, we could use that to measure the heat loss of the building, and that would be a good quality assurance. We could use that to measure U values. I was thinking of smart target setting earlier, where it needs to be measurable. So if it was a measurable metric that's in the design and is also in the build, then I think that would be a next place to go with it.
Brilliant, thank you. We have time for one more very quick question and 3 very quick answers, if there are any more questions. Has to be a really quick one, though.
Sorry. Energy performance certificates. I deal with them quite a lot. Sometimes I think, are they worth the paper they're written on? The advice I certainly don't think is very good. They're better than nothing, I think. What are your opinions, gentlemen, on as they stand? I think there's too much tick box, not enough thinking about it. They probably don't pay the guys enough money,
Brilliant.
and they're probably not as well qualified. But like your opinions.
I think there is quite a lot of value in an EPC. I think it's another thing of think about what you're asking for, so that EPC rating is a cost metric and not a fabric metric and not a system metric. So it's really important to think about what the metric is. So if you compare EPC ratings to energy spend and think there should be a correlation, then I think that's dumb. So I think it's about thinking about what's inside it. There's more than one metric in it, and there's also a calculated fabric performance in it that we could compare to a measurement, and I think that would be a really brilliant small innovation where we could use these tools as a new thing to go into them.
Brilliant. Thanks, Richard. David?
So they're not there to provide the energy performance of an individual home. Every single EPC is wrong, but when you do 1 million, they're fine. That used to be what we thought. Research currently is showing that actually there aren't as many higher as there are lower, and therefore they all average out. Actually, EPCs, we think from current research, are over-predicting, and that's research that UCL have undertaken on smart meters, and it's research that we've corroborated on our case studies, and we will show that in our deep research project where we've modelled and measured the energy efficiency of home. That's really important when you're basing your savings on your EPC score, because if you're saying you're using loads of energy, you think you're going to make loads of savings, and probably not.
Tom, last words from you, please.
I would look at EPCs as a blank tool that tells you that something is good or bad or average. You don't try to get any specific data out of this. It is useful, for example, if the government wants something like private rental sector to move from very bad to average. It's a tool where you can point out 2.5 million homes and say, you need to do better. Right? It's never going to be specific. It's never going to give you any exact savings, but as a national tool, looking at millions of homes that are frankly appalling, it is an instrument that can stimulate action. So let's say nationwide committed to the government that all of the portfolio properties will be EPC C by 2030. Individually, it means nothing. But actually, in aggregate, that could make a massive difference.
Brilliant. Thank you, Tom. Ladies, gentlemen, thank you very much for sitting through the panel. Can I ask you to show your appreciation to Tom, David and Richard, and enjoy the rest of the show. Thank you very much.